Hello everyone. Here in this video, we are solving a problem basing on vectors resolution and will be also learning the concept of it while solving the problem. Let us see what is given in the problem. It is given that there is a particle moving in as shown in the diagram. It is first moving from origin this way, making an angle 45 degree with the x-axis. Then it has moved horizontally, I am calling it like B. Then it has moved vertically up, I am calling it like C. Would like to calculate what is the final position of that vector is. That's what our question is, right? So while solving the question, the first part is a most important part. This part, say this part. It is given that the particle has moved a distance of 5 root 2 meter, making an angle 45 degree with the x-axis. So it is neither along x-axis nor along y-axis. So we shall be able to find how much of that is along x-axis and how much of that is along y-axis. For that, let me draw the diagram of that part once again. This is what given for you. 5 root 2 making an angle 45. So some part of that, this vector is neither along x-axis nor along y-axis. How much of that is along x-axis to find out? You can call that as ax. I can draw a perpendicular line down. So I can see a right angle triangle where you need an adjacent value ax. So you can write cos theta. Cos theta is ax by, if you call this as a. Cos theta is given to you as cos 45. Ax you have to find out. A is given to you as 5 root 2. We know that cos 45 is 1 by root 2 is ax by 5 root 2. So root 2 gets cancels. You get ax equal to 5. So the component of that vector along x-axis is 5. Similarly, you want this is ax. How much of that vector is along y-axis? This is the vector along y-axis component ay. That and this are parallel. So this is also will be ay. I want ay. In the same right angle triangle, I can write sine theta because ay is the opposite side to the given angle. We know sine theta is ay by a. That is sine 45 is ay by a. Sine 45 is 1 by root 2. Ay by a is 5 root 2. So root 2 again gets cancels. So ay is also equal to 5. So this vector 5 root 2 making an angle 45 degree can be actually written as axi cap ay j cap. That is 5i cap plus 5j cap. So we have simply decoded this vector and expressed it in terms of the components. So that's the major part of the problem. Other parts will be definitely appears like easy now because look at this vector. It's only on x-axis. So I can write b bar as 1 meter along x-axis. To say it's along x-axis, I can multiply with a I cap, who is a unit vector along x-axis. Look at the third vector c bar. It's on y-axis. So I can write c bar as 3 j cap. It is along positive y-axis, therefore j cap. So the resultant of all these vectors is how much is your question. So r bar is simply a bar plus b bar plus c bar. A bar is 5i plus 5j, b bar is 1i, c bar is 3j. So 5i plus 1i is 6i, 5j plus 3j is 8j. So that's what your resultant answer is. R bar equal to 8i cap and plus 6i cap and 8j cap. So where is that vector if you want to draw resultant vector? This is what your R is. Where making some angle theta with x-axis. This part becomes Rx, this part becomes Ry. Be careful about the direction of the components of the vector. If the vector is in a particular direction from the origin, components also will have the same direction of that vector. Now this Rx is 6, this Ry is 8. If you want the magnitude of that vector, magnitude of a vector can be identified as root of Rx square plus Ry square. That is root of 6 square plus 8 square. That's root of 36 plus 64. That is root 100. That is 10 meters. But if you are interested to find out its direction, what is its direction of that resultant vector theta is, I can again write tan theta in this right angle triangle is opposite side, because this is Ry, this also will be Ry by Rx. So tan theta is Ry is 6, is 8, Rx is 6, 4 by 3. So theta equal to tan inverse of 4 by 3. This theta value. This is how we can solve this kind of problems. So to solve these problems, the most important part is like resolution of a vector. So how do you resolve a vector is an important part of solving this kind of a problem. You need to resolve a vector when it is neither completely along x-axis nor completely along y-axis. In that case, when it is like this, simply resolve it this way. Resolve it this way. Identify how much of that is along x-axis, how much of that is along y-axis, and finally add each components of this vector, right? You can add I components, j components, and k components of each vector and find the resultant. And of course, you can also find their magnitude and direction as it is being shown in this problem. Thank you for watching.